to look at our speakers and listen to what they have been doing. The agenda for today, I will just give you some heads up about what's going on, and then we would like to express our gratitude to Patrick Nixon, the Dean for the Contract Science. Unfortunately, he's not going to be here with us today, but Corey will be representing him. And then we'll have questions and answers. And then we have James. James is here. Thank you, James, for being here today. I appreciate it. And James will be talking about his research work and his recent grant and his wonderful collaboration with the accelerator and also with the government. And then we have Mark Brookie and Mark Stevens right there. He will be taking from this point and then question and answer. And at the end, if you have more questions, just if you give me a minute here, give you an idea about what's going on. This is the number of proposals that we submitted so far. You can see here every year the number of proposals is going up, and 2025 is not done yet, but you can see the number of proposals awarded for this year. And if you look at the funding, you can see here the $3.3 million, it was 0.8, and then 2.4, and then 3.3, and the year is not done yet. It exceeded what we were able to raise and attract last year, and certainly that's because the faculty member was very active in research, and certainly we realized what's in it for me. If I'm a researcher and I have done that before for a number of years, what's in it for me? Why should I write a proposal? Why should I get funding? Simply because I'd like to be my own boss, to go wherever I want, hire whoever I'd like to hire. And certainly I'm looking for 26. That would be better than 25. And with this, I'd like to invite Corey to say a few words on behalf of Patrick Nixon. Thanks, Corey.
Okay, so because Patrick's not able to be here, he asked me to introduce the speakers, and also he had a couple of things that wanted me to point out. Primarily in terms of reminders about Research Day tomorrow. I know you know about Research Day. 9:15 is our presidential colloquium by Shannon Timmons and Alexander Kuzmanov. They're talking about their recent NIH-funded project. I think they've completed 1 year of the project. And a bit of lore that I've heard about this is that this was the first major NIH grant we've gotten here, or one of the first. I haven't been able to corroborate that independently, but it's an incredible accomplishment and a great sign of things to come. And I happened to notice there were several NIH proposals that went out this year, so I think hopefully that's a new avenue for us, and that's very exciting and a great accomplishment for us. So we can hear about how that's going. After that, we have the first annual College Researcher of the Year Awards. We have two folks from Arts and Sciences who are going to be honored. In this case, the nominations came from the department chairs, and then the dean had to make a decision. I happen to know he had a tough time selecting one person, so he ended up just having to select two people, because there were several people who just had outstanding years. And just people were just crazy productive, so it's really inspiring to see all the things that people have accomplished. And then after that is 11 o'clock is the keynote address by Tina Karani, who's here visiting from San Jose State University, talking about the use of AI and augmented reality for teaching and storytelling. I'd like to think that I know something about technology, but I had a meeting with her about an hour ago. It was a fairly mind-blowing conversation about what she's doing with AI, so honestly, I recommend that you try to make this talk. It's going to be fascinating. Okay. Oh, I'm sorry, and Matt, I'm sorry, I was supposed to stop for Matt.
I just want to say thank you, everybody. There's 134 posters in the afternoon. That's not up there. So after the morning session, and I really need your help because the posters are all student posters. And many of you that are here today are represented as faculty advisors. So I'm really I really want help judging. So what I'm going to do this year is every poster is going to have a little paper cup with the title of the poster, and I'm going to give all the faculty little art beads. You'll have like 20 beads. And just put a bead in any cup. Whatever your reason is. Maybe it was a great elevator pitch. You like the visuals. Just do it. Give as many beads as you want. If you run out of beads, you need more beads, let me know. I have 700 beads. And then we'll just have the beads, and we have 9 awards. So that's how we're going to do it. But I need your help. Okay? And it means a lot to the students that you check them out. We've got 2.5 hours, you have lunch. And then I wanted to say one other thing and I forgot.
It'll come to you after the speaker starts.
Anyways, thank you so much, everybody. And we'll see y'all tomorrow.
Okay. I want to introduce our speaker, our first speaker of 2 speakers, Dr. James Minders. James is an associate professor in mechanical robotics and industrial engineering. He's the director of the bachelor's program in robotics engineering. He's the director of the master's program, mechatronics and robotics engineering. So he's very busy over there. James got his PhD in mechanical engineering at Purdue, correct? And if I remember correctly, you also got your bachelor's degree at Purdue University. So you could scarcely do better if you want to go into engineering than to get your education at Purdue. And it's awesome that we have him here on our team to bring some of that. And his topic is related to recycling critical materials from batteries. I'll leave it to you to put up your own title, but
Sure.
this
Yeah,
is a collaboration.
different title, sorry.
Okay, that's not the title. I didn't say
No.
that. There you go.
No, the instructions I got were a little more vague, so I went with just giving you some background on my experience with industry-sponsored research. So, you changed the format a little. Establishing some credibility here. I've got about $4.2 million in research funding since I started in 2012, although I will hedge a little bit and say that some of that coming off the grant I'm going to talk about today is a little different than how we normally count things, so about 2 to 3 million of it is co-PI or PI. Over 50 publications, and then tech reports are something that's interesting when we talk about industry-sponsored research. Some of the work that I've done has been confidential, and so we never got around to publishing it, right? So we instead submitted confidential technical reports to the sponsor, and for those of you that are still working on tenure, I put them in my CV for tenure and promotion, absolutely. There's still dissemination, but it just doesn't go out publicly. Also, a provisional patent and some theses and dissertations. I'm also proud of the Engineering Unleashed Fellowship and the Excellence in Teaching Award back in 2017. So, what I figured I'd talk about a little bit is my own experience in working with industry, and then get into one specific collaboration with Centropolis for the battery sorting and disassembly project, which is what's going on right now and keeping me pretty busy. So, one of the things that I've struggled with as long as I've been here is how to make those connections with an industry partner that might give me money at some point. And so the things that I have been told over my career have been, talk to people that you know from your previous work experience. Well, I came straight out of a PhD program, and the various internships I did, they're not going to fund me. So I don't have work experience in this area that's going to get me access to a funding agency. Personal connections. I didn't grow up around here. I don't know people in the automotive industry on a personal basis. I've got friends elsewhere, and most of them went into academia. So those two didn't really help for me. Students, though, students are something I do have. I have current students, I have previous students, and depending on how long you've been here, Dow's a good example. We have students that have moved into management roles. And those students in management roles now have authority to start signing off on projects. And so that's been one thing that has worked for me, is working with current students on projects for their employers, funded or not, and then working with my previous students as they move up in seniority and have authority to start signing off on projects. Another one that works for me is adjunct faculty. At least in College of Engineering, we're using a lot of adjunct faculty that are working full-time. As a program director, I'm responsible for finding them, for hiring them, for managing them, which means I'm in regular contact with them. And so that's been an advantage for me personally, and maybe it's something that can work for you as well, but I use adjunct faculty sometimes as a source of funding, and I'll give you an example of that. Advisory boards, I know we talk to our advisory board regularly, and I feel like every 6 months we meet with our advisory board and we say, who's got a project idea? Who's got a $50,000 project? And the room stays silent. And that one has never worked for me. I have yet to see anyone raise their hand and say, yes, I'd like to fund a project from our advisory board. And I'm hoping that Mark can help us fix that. I know Tom and I have talked about that a little bit. But the best one on here for me has been Research and Economic Development and Centropolis. So in particular, Mark and Tom and Pedro. Those have been big sources for me for research funding from industry. So give you an example. Back in 15-ish maybe, Mark came to me with some small local company he'd been working with and said, hey, can you talk to these people? And they had some crazy out there ideas, but they gave us a project. And we worked it, and we went back to them, and they said, hey, here's some more crazy out there ideas. And we put together proposals for those as well. And we didn't get more funding, but credit to Mark for bringing them in the first time. And so making sure that Mark knew what I was interested in helped get those sorts of grants. I'll also talk about Centropolis a bit later. In terms of student connections and adjuncts, just some examples from my experience. I had a student that graduated from the master's program, top performing student. We hired him as an adjunct then. He was good. We went ahead and brought him on as an adjunct. He taught for a number of years until he got a promotion and got married and bought a house, and then he was too busy to teach anymore. But he's now a director of engineering at a tier 1 supplier, and so he reached out to me about 2 projects recently. There was an opportunity to do some training for his direct reports, so we put together a proposal for that. More recently, there was an opportunity to do some modeling related to robotics, and I said, this isn't for me, but Dr. Vajani can do it. And those didn't hit, which is unfortunately a common theme. But we've also then submitted a white paper to him, said, hey, this is a project I'm working on right now. Would it be interesting to your company? And the answer was yes. So we're working through the possibilities there to now make a case that there is value to his company. I also had an adjunct that taught for us for a number of years. I mean, he taught for 10 years, but it was off and on. He didn't teach every semester. But he came in and said, I've got a startup company and I want to fund a project. And so it was that personal connection of knowing that we've been working together regularly. He brought me a small project that turned into an invitation for an international collaboration, which also wasn't successful. But those connections started building options there, right? So kind of the takeaway from this for me has been that industry engagement is really slow, right? And maybe you've seen something differently, but by and large for me it's slow. Every time I meet with a new company that's got some possibility of funding my work, we start off with discussions around what their needs are. We talk about what we've got in terms of capabilities and do a tour. We go see what they're doing and do a tour. And we try to get back to what are the actual problems that they are experiencing. The long-term back burner problems that they do not have enough man-hours to solve. The things that are wish list items, but not today's problem, but 6 months or a year down the road would be great to have. The things that we can start to address. And frankly, 75% of the time, there's nothing there, right? We talk and then nothing happens. And that's not unusual. But if there is something there, then we find a team, we put together a proposal, and then we go and pitch it to them. And frequently there's nothing there. But if there is something that we propose that they liked, it turns into an opportunity to iterate, to get closer to what they want, and frequently there's nothing there. But every once in a while it leads to a project, and frankly that one project covers the time for all those other failures, right? It takes a lot of effort. I know when we talk about federal grants, we talk about, they fund 10 or 15% of what they receive. And so you got to submit, 10, 20, whatever to get grants. Same thing with industry. But we're doing a lot of the time talking to them about their problems, not necessarily grant writing and sending it out the door. So as an example of this one, we worked on a project, Leaping was on this one, with JCI Power Solutions. We started back in 2015. We attended their technology day. This was again something Mark brought to us and dragged us to the technology day. We had to travel, go see what they were talking about, see what their problems were, and we put in a proposal and they didn't fund it. And so we did it again in 2016. We looked at their problems, we attended their technology day, we put in a letter of intent, we submitted a proposal, and then they wanted to call and talk about it. And we talked about it for a while, and eventually they gave it to us. But over a year to get to that point. It turned out to be an 18-month, $180,000 project, which was nice, but it took a lot of effort to get to that point. We had to, keep trying over and over. And we did a good job with that one. I liked that project. We got the thumbs up from Mark on that. Yeah. Another one more recently, and this was something I was working on with Tom. We did a tour for an OEM, a tier 1 supplier around here, and there was some big picture discussion with them. We did more discussion with them. We changed the size of our team. We did a tour of their facility, and then eventually we got together and we gave them a proposal and we gauged their reaction. And most of their reaction was, some of it's good and some of it's bad, and change these things. So we ended up changing the team and doing a new proposal, and then we got the response from them, this is great, we love it. And we thought we're doing well. So then between March and May, we were just waiting, and finally they came back with the idea that this was a $600,000 proposal. We'd really like to see what you can do with $50,000. Yeah. So we did, we gave them a $50,000 proposal, and frankly, we never heard back anything from that point. The LTU champion within the company retired, and I think that was the thing that did it. But we formed a good team with this. We're continuing to work, and so we've now got a workshop running next Wednesday. So looking forward to this. Although this particular project proposal was a failure, the outcomes of it, I think, are going to turn into something really nice starting on Wednesday. So there's a lot of opportunity to take what we learn from these and roll them into the next project. In each of these cases, we put together a proposal, and one of the things that I think is always interesting on these is that we are writing to their specific problems. They've told us what their problems are, what their interests are. It's not about what my particular research agenda is going to be. It's about what they want solved. And so it has to be very tailored to them. It's not basic research. It is very much application specific, answering the question. That's it. That's what they want. As short a timeline, as cheap as possible. But you also on these have to get outside your comfort zone. And I think adding more faculty from across the university has helped. Making multidisciplinary teams, adding more folks from outside your own department, it helps. It really does. And in writing these, I found that we need to be very clear on the tasks and the deliverables. So, especially with the JCI project, I remember we got into it, and then there's a question, well, what about this? Well, it's outside the scope of what we said we were going to do, but, you're asking for it now and you're paying. What do we do? I think the clearer we can be with the tasks up front, the better we can be later. Also clarity with the communication during the project. So as an example, here is part of a task description that I wrote for the Tier 1 supplier example. So we started off with, we're going to do a survey of technology, we're going to do a survey of the literature, we're going to benchmark the competitors. We laid out every single little line item. I tried to make it as detailed as possible so that I understood the plan and they understood the plan, so there wouldn't be creep later. I also tend to write out the deliverables and tie them right to those tasks. The first 2 tasks got rolled into one deliverable, the next couple of tasks got rolled into the next deliverable. I learned my lesson from the JCI project. We had 11 different deliverables over 18 months, and that is ridiculous. Don't ever do that. 3 is a good number. Other things that were valuable to some of these proposals, listing off the relevant labs. A lot of these places we talk to, a lot of these companies we talk to don't know our capabilities. That's been a common theme, that they don't know what we're capable of doing. They don't know the equipment we have. They don't know, it's always that we're a diamond in the rough sort of thing. No, tell them what you got. lists every possible lab that you might use, but also what resources we need from them. Do we need material samples? Do we need information? Do we need expertise? Explicitly list off the resources required from the partner. There's always a list of assumptions in terms of IP and everything, but we need to be absolutely clear with those things up front and obviously justify the budget. So this is sort of a standard template that I've got for all my proposals for industry partners. Certainly, anyone's welcome to a copy of it. So one specific one that I've been working on recently that there was an interest in here was a project with Centropolis. So who's already working with Centropolis? Anybody? Couple, yeah. So Centropolis is great because they've got connections to a lot of different companies of a lot of different sizes. And so they can help you with introductions, they can help you with projects. They are a great way to connect to the different companies, but they're not the only option. I want to be clear, they're not the only option out there, but they're a good one. So the project that I'm working with them on is about autonomous disassembly and sorting of batteries. And this is a sort of a national supply chain problem. We know that for lithium-ion batteries, the material supplies are dominated by China. There's a huge demand for domestic supply, especially with the increase in EVs. So what do we do about that? Well, the Michigan Department of Environment, Great Lakes, and Energy had a grant opportunity to support research into the reuse of critical materials for clean energy production. So we said, okay, we can address this on two sides. We can take EV battery packs that are end of life, and we can tear them down. Well, people are already taking them and shredding them, but the purity is not there. You can greatly improve the purity and the value if you can disassemble them and get rid of all the extra stuff, all the plastics, all the various metals from them there, and just be stripping down the black mass. So we've got EV battery packs coming in from the OEMs. Ford and GM are providing that. Stellantis is a backup. We've got a local company, AIR, is doing automation design for us. My students will help with parts of that. We'll do the demonstration of the disassembly here using the equipment from AIR, and then Monroe will do the techno-economic analysis to be able to talk about the actual monetary value of all this. And then the other part of it is we have, on the consumer side, we've got all sorts of batteries that are going into the recycling streams that are ending up at your recyclers like Padnos and Great Lakes Recycling and Goodwill Industries. And so we're going to take samples from them, and we're going to use another industry partner's AI battery classification system. They have a vision-based system, so it's looking at the markings and the coloration and everything on the batteries and using that to classify, and we'll develop the robotic system to then move them into the correct bins. Manually sorting is the standard right now, so we can make that a lot more efficient. So we'll do the demonstrations in-house, and then Monroe will do the techno-economic analysis again. You can see we got a bunch of partners right there. It's not just LTU. The organization looks like this. We've got Centropolis as the lead, and then I'm essentially a subcontractor to Centropolis. It doesn't work that way because they're in the same, we're both part of LTU, but functionally I'm a subcontractor. And then all of those other boxes are partners that are also serving as subcontractors here. And they brought in all of those, which is great. I didn't have to make those calls. I didn't have to know these people. Dan and Pedro made the calls and brought these folks in. So that saves me a lot of hassle. I can just focus just on the robotics portion. Down here, Joe is our program director. Sometimes we talk about program managers. I know when we're doing traditional academic research, the PI is responsible for everything. I appreciate that Centropolis is using program managers for a lot of their projects, and so Joe handles the communication with the external partners. Joe handles setting up the slides when we're meeting with the external partners. Joe makes sure that the timelines are working, and then reminds me when I'm supposed to be doing things. So having that program manager takes a lot of the weight off of me, so I don't have to worry about all the PI things. I can focus on meeting with the students and handling the actual technical part that I'm responsible for as a subcontractor. So I recommend working with them with this model. It's great. Things that we're actually doing right now, I've got 4 students hired. We've got a space out at the ARC that was previously underutilized. It had some equipment that was never in use. It had the student team that could have moved to another space. So we've renovated that as a new research lab to support this. And we've gotten in the first piece of equipment from one of the partners, about $100,000 worth of equipment donated. We're working on fixing that up. And then we'll be getting in the consumer and EV battery packs pretty soon. So we're making good progress, but you know, it's a huge endeavor to collaborate all of this. So when I'm thinking about things that we can do to be more successful, there are my 4 recommendations. First thing is just engage with your current students, right? So it doesn't matter, I think, too much whether it's funded internally or externally, but put them on a research project, a classroom project, whatever you got. Having a current crop of students is great when you do get a project, and those are potentially the students that are going to value research when they graduate and are going to be, you know, 10 years down the line, they're going to be your sponsors. When we're trying to organize something with an industry partner, it takes so long. Persistence is critical in order to get these projects over the line and funded. There's just, the timelines are so long to get them to sign, and then the timeline to do the work is so short that you got to be persistent. And then throughout that time, there's also all these changing requirements, so flexibility matters when you're working with them on the proposals. Being able to work outside your comfort zone and bring in people that you may not already know. And then collaboration within the university is great. Collaborating across between faculty and economic development, faculty in Centropolis, faculty in other colleges really matters. So that's what I've got. I'm happy to take questions, or you can email me if you got questions other than right now.
I have a question. It's not a question, but would you say the robotic lab that is funded and provided by the industry help you focusing and attract more of industry? Can you elaborate more?
Yeah, so the Rockwell lab, yes, that is a showpiece that certainly is getting attention. It hasn't produced a huge amount of money coming in, but yeah, every time I talk to people, they're interested in what we're doing and what we're capable of doing. It's serving as a platform for both automation work, but then other things that we can use, bits and pieces in there, vision systems or using the conveyor. Yes, it's helped, absolutely.
Can you elaborate how you were able to bring that lab to reality?
Well, let's start with, it wasn't just me, right? So Mark and Elin and Li Ping and George. Who else am I forgetting? Anyone? Well, Nabil, obviously. Yeah, that effort with Rockwell started in 2019 and took us until 2023 to get the lab done. But I mean, we ended up with $1 million improvement in the lab. So I'd say it was worthwhile. And it continues to help us, and we're gonna see increased usage going forward with more classes in there.
Thank you, James. Great presentation. Just a question. Let's suppose that you have a contract with an industry, with a company, and then there is something that is external to the company that prevents you to deliver in time the outcomes that you are expected to deliver.
Yeah.
Because something similar is happening to me, and what kind of strategy would you suggest if you have a lot of experience?
Yeah, so we saw that with the JCI project, that we got to a certain point and realized this is not technologically feasible. It's just not possible. What we did at that point was we scheduled a call with them, and we told them as clearly as we could why it wasn't going to work. And we had a proposed plan to do the best we could with what we could do. You know, what we couldn't deliver on what we promised, but what was the next best thing that we could deliver? And we did that as soon as we realized that we needed to change focus. So at that point, it was a little bit like redoing the proposal, right? You know, changing the deliverables, changing the milestones to adjust for it. But we were pretty clear with the sponsor as to why it was happening and what we would do to help them.
You told us that some students are working for ISP projects. Are they getting course credits?
That's a good question. So we do industry-sponsored capstone projects, and so yes, I've had students work on those where they're funded by an industry partner and they're getting capstone course credit, yes. I've also had some that worked as, in engineering, what we would call a directed study project, where they were doing a 3-credit research project by themselves with my supervision, and they were getting course credit. In one case, it was a grad student that was doing a project related to his employer that was specifically helping a problem that they had, and so he got course credit. He was getting paid by the employer, obviously, but not by me.
If I understand correctly, in your project that you presented, there's robotics involved in the sorting of the batteries, and you were a part of this large group of people. I'm curious how you got into that position. Did the project originate with the Centropolis and they found you, or did you come up with the original?
Oh, it originated with Centropolis, and at some point, I got to go back in my emails. At some point, Pedro reached out and said, "Hey, can you help us with this?" And I said, "Yeah."
So just to make it more specific. So if the intellectual property is not given to Lawrence Tech or not shared by Lawrence Tech, totally up to the company who funds.
That's a good question for Mark and Lee-Ping and Catherine and Nabil. Most of the ones I've been dealing with here, we were operating under the old IP policy that the company owns everything. But my understanding is we're switching to having a more flexible IP policy. I think it would really depend on the specifics of the project agreement.
So my question is, if schools are involved in that kind of projects,
Sure.
whether they can do the work for classes.
Yes. Yeah, absolutely. So we did a capstone project with Eaton sponsoring, and they had a particular widget they wanted us to design, and the students designed the widget and tested the widget and delivered all of it to them, and it's all considered confidential in their IP. Yes, absolutely.
Thank you.
There you go. All right, thank you.
He's all sort of ever present, talking to us regularly about opportunities. Mark's the Associate Vice President of Economic Development. Before that, he was the founding executive director and governing board member of the Centropolis. Mark is a Blue Devil. He got his MBA here at Lawrence Tech. He's one of us. And the word on the street is that he is an avid boater and grill master also. So these are good things to know about your colleagues. So I'm not going to try to guess what you're going to talk about. I'll leave it to you.
Well, great. Thank you, Corey, and thank you, everyone. So we are in the midst of I think this is the 5th session of our series on the NSF grant and focused on industry collaborations. And so number one, what I wanted to be able to do is there's a couple sign-in sheets here. So if you haven't signed in, let us know, because we keep track of these things for the stipend that is available, and just keeping track for the NSF grant about who's attending these. So please do this. I will say, where's James go? James had the award for the best Gantt chart that JCI Research and Development had ever seen. When he submitted his proposal, they couldn't stop raving about it. I mean, it was great. But in the timeline also that James outlined for JCI there, we had 2 other awards. So this was a comprehensive research relationship with JCI before they dissolved. And I'll go back to his slide where all these icons that we're moving around. Our job is to get to know you and your research as best as possible, so we can mitigate all those discussions with industry and bring to you a vetted company as much as we can. All right. So the more we get to know about you and your work, the more conversations we can have with industry, and we can then make the best use of your time, given all the things that you have to do, to be able to sit down with a vetted industry partner, and it still takes a long time to get done. So with that, I wanted to be able to let you know that we have one more session coming up next week. I'm sorry, this is, next session is May 22nd. That's an error up there on the 1.5 days. But it's a prep for on May 2nd. Then we have this 1.5 day workshop. We'll be having an agenda out real soon. And I want to really highlight this faculty stipend agreement. We are now, I think, up to, I don't know, 17, 18 now. This is absolutely great. So one of the things that we want to do coming off of this is we are going to be doing a specific game plan, research agenda for each one of the members that have signed up for this, but also regardless of if you signed up or not for this faculty agreement, please attend the 1.5 day workshop, and we'll still, we're still looking at being able to work with you in depth on getting this done. We've also had probably several more faculty research profiles really come in this week since this slide deck was done, so we're getting there as well. And earlier this week, we sent out a faculty survey on AI expertise. We have something like 45 surveys in 2 days, which is great thus far. We're looking to have more. There's just so much going on in AI. We want to make sure that we understand as a university what people are doing so that we can engage our industry partners at a higher level and more than that. Last time we talked about where to find some of these industry partner objectives and information, and a lot of you have talked to me about these or sent us information on these. And so what we really wanted to do, we've talked about this several times over the last couple of sessions, but really today is an exercise. So what we did is handed out here is just to be able to get some feedback, have you spend a few minutes completing these, turning them in. We'll make copies, send them back to you so you have copies of what you wrote down. But I wanted you to go ahead and just start identifying real quick what you've done, like what your expertise is, what kind of problems are you looking to be solved, and at least 1 or 2 industry partners that you want to be able to contact. And part of this is being able for us to understand who's here. So go ahead and start doing that, and while you're doing that, I want to highlight a couple things that we've had some feedback on already. So we have people that are interested in biomaterials and tissue engineering and biomedical devices, and we have company. Part of this is also identifying who wants to talk to the same company, right? So like we have Zimmer Biomed and Tissue Regeneration Systems that we want to talk to. We want to talk to Tata Technologies and Wolfen by Toyota about autonomous vehicles and robotics. We want to talk to on AI, machine learning, Amazon, NVIDIA, Lockheed Martin, Tesla, companies like that. And there's also a lot of different distributed computing and distributed and blockchain machine learning areas that companies like Altair and Fairsight. Some of these companies we have really good working relationships with, but some of these we don't. I mean, these are going to be new relationships that we want to open the door of. And typically what we do with these kinds of relationships, just like James was articulating, it's sometimes who you know, right? So number one, we'll ask other faculty if they know anybody at these companies. We have the extended version of LinkedIn. We look for alumni. We coordinate with Kevin Finn's group on any other kind of alumni connections. We try to find a champion. So one of the projects that's going on right now, we discovered through Halo, and it was posted by Henkel, I'm sorry, and we have a vice president of engineering that is part of that group, and he's on an advisory board here. And so he's helped us really navigate, there was actually 2 grants. One of the grants didn't make it, the other grant's still in progress, but we want to identify who those are. And then we also, under the research, the new Research and Economic Development organization, we created a University Industry Advisory Board. We had our first meeting last month. And so we also have these, trying to make it to be more active industry advisory board where we can go to those companies and say, can you refer anybody to us in regards to these technologies? So we also are looking at, like, a lot of times, like Dr. Grace has had a history of grants from MDOT. Matter of fact, we're an MDOT Center of Excellence. But there's other things that MDOT does too other than bridge work, right? So we want to be able to look at where we have some relationships and, folks want to talk to these organizations. We can leverage some of the things that we have done before to get into other organizations. And so I just wanted to be able to sort of make this a little bit experiential. And so while we're doing this, is anybody willing to share some of the things that they put down on there? I see Corey working away here. And so I think, George, you got yours all filled out. I think maybe some of the challenges, just like you face, maybe you're going to be reading some people's handwriting. But George, you want to talk to us a little bit about maybe some of the things that you've written down?
Sure. So I guess the one thing is listed here is research expertise. Some of the projects I've done, kind of like what James mentioned earlier, relates to machine learning, natural language processing, and it depends on the project. That if I had focused or heavier on algorithm optimization or versus an application. So again, problem to be solved. Main thing is algorithm optimization and machine learning, and also predictive prescriptive maintenance for the recent project with Ethan, and a list of one industry partner that you'd like to connect with. Again, NVIDIA was on top of my list, and then AWS.
Okay.
And that's about it.
So with NVIDIA, we have a great working relationship with the lead. They have different titles, but he's sort of like vice president of NVIDIA here. He's with Epic Unreal and Macavision before that. So we brought him in. He helped us guide the MRI, the Major Research Instrumentation Grant, and provided us information for that grant so we could open those doors. Part of the other process here is what James pointed out is faculty collaboration. I've worked with George for a number of years, got a good idea about what he does, but by doing this and submitting some of this information, we can understand who we might be able to bring together in terms of working across disciplines. And so it's really good to have part of the grant is Lee King and Matthew Johnson and Corey are all part of the NSF Epic grant. So we can look at how we can create more interdisciplinary opportunities. So thank you, George. Anybody else have CJ?
Yes, you have a kind of standard indirect cost link for ISPs.
So typically, ever since Maria Vaz, many years ago, our former provost, we pretty much established a 20% indirect charge for industry partners. And that, we start off there, and if there's any fluctuation from that standpoint, we have to seek approvals, but it's basically at about 10%.
I paid 30% before for the, this
me different because I'm not an engineer or a computer scientist. I'm a cognitive scientist, so my background's in human factor psychology, some with virtual and augmented reality, human-computer interaction. So the problems that I can help with are things related to user experience, learning, decision-making, situation awareness, cognitive workload assessment, which is important for whether people are going to use your interface. What I like to work with, I'm aware of Stardock, and I know a little bit about Borom. I've spoken to them a little bit. I'd love to learn more about them. But if you can figure out a way that I can speak with Ford, GM, Toyota, they all have human-machine interaction laboratories here. I'd love to talk to those folks.
Great. So what Corey brings up is a level of collaboration. We have existing partners. He's worked with Ben Blau and Stardock on this, and sort of, where's Franco? Sort of like this eye tracking, but virtually, and personality aspects of this, of digital avatars. But then, we had a great conversation with Philip Plowright from the College of Architecture and Design recently, and they have a whole huge area of human-machine interface and user experiences. And so these kind of conversations help us. We have a colleague that's now part of simulation and design within General Motors research, and he's been feeding us information on virtual product development that this applies to now. And one of our partners that we came across in Covisa, which is run by a Lawrence Tech alum, he's got a UX working group as part of that. So we have some ability to make those kind of connections. Did anybody else here have any other elements of their research that dovetail into what Corey just talked about? Human-machine interface, other aspects? Okay, right? So
I attempted to do some research on eye tracking for ad placement on web pages, the way they interact with the user. I was planning to do this with COVID, and I couldn't use the lab. And I lost the students who were actually doing that work. But I would love to kind of get back to the work.
and I know a lot about what Eric's been doing. So right here we have at least 3 people, all in the same college right now, but I know that we also have a lot of people in the College of Architecture and Design and elsewhere. Anybody else would like to share what they jotted down? Got anything?
I think I'm so overlapping with Corey in the field. It's very difficult to say something different. So just sharing what I wrote here to say problem to be solved, and I said any human factor aspect, specifically user satisfaction and performance, because it's not only satisfaction, how people are happy in using the designs that you technologies create, but also in the performance, right? Optimization of performance. This is something that Corey, I, and also Ahmad, we worked on that for 20 years. So this is what we do and what we can do in collaboration with you. Even when you design something or you help companies to design something. So, yeah.
So, given that level of collaboration, this is one of the, more specifically, Franco is one of the folks that have put forth the faculty agreement. We wanted to be able to drill down on these projects, identify them, scope them out, and then collectively go out there. It's always going to be better for us when we go to industry partners to say, when we start talking about why Lawrence Tech, as James pointed out, that we can show depth of bench, right? We want to be able to show the faculty level of expertise. And time again, in working with Dr. Grace, it's like, who are our faculty experts in this, right? And for the longest time, we had one. We'll have James, right? And I can only go to James and bring James so many industry partners and then he's over his head, right? Well, now we have this great cadre, all these experts here at Lawrence Tech in terms of your faculty expertise, and we want to be able to identify those experts and our expertise and be able to promote that. And so that we can sort of shout out about it a little bit more on our website that we're creating. And that's another reason for this faculty experts in AI. We want to understand our expertise in this area. So maybe we have time for one more. Anybody else willing to share? Yes, go ahead.
I don't know if it's so close to that, but I wrote like problems we solved like skill training and learning acquisition using multi-modal virtual reality haptics-based simulations, where we can use these kinds of multi-modal even user interfaces to teach model skills or train model skills or learning skills. Yeah.
Great. Any companies specifically?
I didn't say like any companies, like in general, like medical or vocational skill training.
So, a lot of the things that we've been talking about in these short sessions are incremental components here that's going to lead up to this day and a half worth of training. Okay, we're bringing in Christopher Kitts, he's Associate Dean of the College of Engineering at Santa Clara University. And there's elements of what we've been talking about that are going to be within this day and a half training. So we're going to culminate a lot of these 6 sessions that we had to be able to help you move through this day and a half with much more added value than if you just showed up without having any of these experiences and this information that we shared. So thank you for your participation. Thank you for engaging on this. We really want to scale up our industry partners, especially at a time when there's so much pressure and uncertainty in federally funded grants. All right, we want to be able to talk to our industry partners and tell them that we can help them out, we can help them solve their problems. It's a good investment to invest at Lawrence Tech because we're nimble, agile, and we can get the problem solved, right? It's not just a project, we're problem solvers, and that helps us get these companies aware of what we're doing, gets them in the door, and get them in front of you so you can shine in front of them. Thank you very much. If there's any questions, I'd be more than happy to
Just to have a question here. CJ talked about, I believe, patent, a minute ago. He asked a question about the patent.
Yeah.
Okay. I can tell you one thing for sure. When you write a proposal, I can tell you my own experience. I had a proposal with the Army, and I worked closely with a scientist in US Army. And when it came to time to develop a patent, at the end of the day, it was my intellectual property. And it was my property. So he agreed, which is a government, which is the Army, that the patent would be, he would be a co-inventor and I would be a co-inventor, but it would be owned by Lawrence Tech. And we signed an agreement on that. So it depends on your proposal. It depends on how you're going to set the stage moving forward. I thought to share that with you. So when you write a proposal, make sure that if this is your intellectual property, put it in the proposal that you'd like to discuss this, and we can get some help from Mark and Catherine.
Just to build on that, we have our intellectual property policy, okay, that outlines what we agree to as a university. However, any statement of work that is created supersedes the policy. So whatever is scoped out in the scope of work is what we follow. It supersedes what's the policy. The policy gives us a guideline, but in a lot of cases, our selling point to industry has been, we give you all this IP because what we want is your funding, we want